Okay, now the third questions. A leaf of mass 1,200 kilogram is suspended by a steel cable. The leaf can move upwards at a maximum acceleration. That means it accelerates up. Now it's not equilibrium. It has acceleration. Of 1.5 meter per second square. The maximum tensile stress that can be withstood by the cable is 120 megapascal. Mega need to change to SI unit. Determine the minimum diameter of the cable. Why suddenly have minimum diameter? Minimum, maximum stress, minimum diameter. What's the relationship between maximum stress and minimum diameter? Later we will see. Okay, so information given, so it asks for the diameter. Information given is the mass. You have the mass, you have the acceleration. This thing is not equilibrium. It has acceleration upwards. Stress, okay, this is the stress. 120 megapascal. You need to change your SI unit. And you need to find diameter, which is stated minimum. Okay, first of all, this is the system. Okay, a cable, a steel cable pulling on the leaf. This is the leaf. Okay, and this leaf is accelerating upward with 1.5 meter per second square. So it's back to the Newton's second law. Total force equal to ma. Go back to chapter forces. Newton's second law. So still remember, follow acceleration positive. Still remember the sign, positive, negative sign. Positive means follow acceleration. Negative means opposite the acceleration. That's how we determine the sign of the forces. So follow acceleration positive, opposite the acceleration is negative. So I can see tension is positive because it follow acceleration. Mg is negative because opposite acceleration. So apply this into the formula, total F equal to ma. So the tension is positive because it follow acceleration, and mg is negative. Mg is negative because it opposite the acceleration. So from here, I need to find the tension. Normally we always find the tension. Okay, so we can find the tension. Tension is equal to mg go to the other side. Mg go to the other side, so mg become positive. So now I can get the tension. And mass can be factored out. So tension is what's the mass? 1,200, and then acceleration is 1.5, and g is 9.81. And so what I get? 13,572 Newton. That's the tension in the steel cable. So this tension will cause the stress in the cable. Okay, this tension. So stress is actually, what is stress? Stress is force over area. Why the cable has force? Why the cable has force? Because it has tension. So the force in the cable, is the tension, isn't it? The force in the cable is the tension. Tension. So just substitute F with tension. The force in the cable. Remember, the force in the cable is the tension. The tension. Now I got the tension ready. Now, just now he mentioned maximum stress, isn't it? He mentioned maximum stress. I need to change the color. Change to yellow color, isn't it? More beautiful. Okay. I don't like the peach color. I like the yellow because it shines brighter. Okay. So okay, let's back to business. Just now he said maximum stress. Yes. The maximum stress means the minimum area. Minimum area. You see? So when I have maximum stress, minimum area. When you have the minimum area, means you have the minimum diameter. You see or not? That's why he mentioned what? He mentioned the minimum diameter. Now, do you get that? Because it's inversely proportional, you see? The stress is inversely proportional to the area, and that's why also stress also inversely proportional to the diameter. Maximum stress, minimum area. When minimum area means minimum diameter. Okay? Minimum diameter. Okay, let's find out the area first. I got the tension already. So stress, the maximum stress can withstand is 120 megapascal. So mega is exponent 6. Change to SI unit. 100 megapascal. Mega is exponent 6. Change to SI unit, pascal. Yeah? Mega is exponent 6. Okay, remember? Mega is exponent 6. So, okay, I already changed to SI unit. So now I can, tension I already have 13572. That's the tension there. I got it. And I can find the minimum area. The minimum area. So what's my minimum area? My minimum area. Amin. Amin. Okay, 1.131 exponent -4 meter square. That's the minimum area. So for minimum area, I can find minimum diameter. So by default, he didn't say what shape of the area. So normally cable is a circle area, isn't it? For cable, if didn't mention and what shape is it, the cross-section area should be by default a circle. You know what is mean by default? Kebiasaan, yeah, or typical, yeah, typical. So the typical area is a circle for cable. It didn't mention what shape, means by default is a circle. So for the area we use, if a circle, it is pi r square or pi d square over 4. If diameter, because now we want to find diameter. If find radius, then we use pi r square. But if find diameter, we straight away use pi d square over 4. Okay? So I got the area just now. Just substitute inside. And that's it. Solve problems. Another easy questions. Okay? So I can find the diameter already. So just this is the minimum diameter. So minimum diameter is you just cross multiply and you will get 0.012 meter. Yeah, because SI unit meter square, so I get meter for diameter. 0.012 meter. Is that correct? Yes, this is 0.012 lah. Yeah, 0.0. The diameter is 0.012 meter. Okay, that's it. You see, force apply. I mean, the equation apply. Newton's second law. Find the tension. And then the force in the cable. Force in the cable is always the tension. Use the stress formula. Force over area. Find the area. From area, always can find diameter. And by default, the shape is always a circle. Okay, unless he mentioned specifically is another shape like square, rectangle. If didn't mention anything, by default it's a circle. Pi r square or pi d square over 4 if asked for diameter. Remember, always change to SI unit. Like megapascal, change to pascal. That's it. All you have to take note. Yeah, that's it for question 3. See you in question 4.